Okay, time value of money problems. Again, you need to think, are we talking present value? The present value of something given some future amount, or discount rate, which we don't use rate of return, but discount rate with present value, or future value where we have a rate of return and what something's going to be worth in the future. Present value or future value. Are we talking a value of one, like a single one-time investment? Or are we talking an annuity or an installment, or we're making an investment every year? That would be time value of an annuity versus a time value of one. So here we're wondering, okay, we have $2,500. It's compounded annually, 4% interest for 10 years. Well, you probably see that's going to be 2,500 times, and pulling our table over, 4% future value interest factor of 1. Single investment, what's it going to be worth in the future? 10% at 10 years is 1.48. 2,500 times 1.48 equals 3,700. 3,700. So our $2,500 investment is going to grow to that. Okay. All right. Question two. If you deposit $10 in an account that pays 5% interest compounded annually, how much you have at the end of 10 years after 50 years? Okay. So part A would be 10 times 5% rate of return. What's it worth in the future? What's it worth in 10 years? 5%, 10 years, 1.629. Hello. 10 times 1.629, you can probably see, just shift the decimal, is going to be 1629. Part B, 10 years, $10, times, what's with a rate of return of 5% for 50 years, what's that going to come to? 5%, 50 years would be down here at 11.467. It's going to grow a lot in 50 years with compounding. 11.467. So we have 11.467. So we're going to have $114.67. A $10 investment will turn into that after 50 years with annual compounding. All right, complete the following solving for the present value PV. Okay, so answer A, we have 10,000 times 5% for 5 years. Present value of 1. Present value of 1. So we have what again? 5%, 5 years. So coming down here, present value of 1, 5%, 5 years, 0.784, right there, 5%, 5 years. We would use a term discounted, which means we're lowering the value of our future investment to state it in present dollars before interest hits it. So we'd say that's the discount rate, 5%, not the rate of return, the discount rate, because they're reducing the amount of what we're calculating. So 10,000 times 0.784 equals 7,840. Next one, 563,000 times 4% for 20 years. 4% for 20 years. 0.456 is our discount rate. Again, we're looking at what something is worth in the future and what's it worth today in today's dollars given a discount rate, which in this case is 4%. So again, that was what again? That was 0.456. 563 times 0.456 equals 256,728. Okay, now I'm going to just double check that. 563, I'm using Excel over here, by the way, times 0.456, 256,728. Perfect. Then we have 5,000 times 5.5% interest rate for 3 years. Okay, this might be interesting. So back to our table. Who did 5.5%? Oh my goodness. Present value of 1. So 5% for 3 years is 0.864. 6% is 0.84. Can I assume that 5.5% is going to be the average of those two? Here, I'll pull this over here. 8.64 and 8.4. All right. So let's go down. Well, actually, we already went down between 5% and 6% after 3 years. I would take those two and probably average them and come out with 0.852. Now you can calculate that 0.864 plus 0.84 divided by 2. 0.852 is our discount rate. Averaging those. 5,000 times 0.852. I got 4260. Pretty close. Exactly, it would be 425807. So I'll just put that as well. If you came up with that, you're in the ballpark. I guess I was in the ballpark with my original answer. That's even closer. Okay. Suppose you want to have $500,000 saved by the time you reach age 30, and suppose that you are 20 years old today. Okay. If you can earn 5% on your funds, how much would you have to invest today to reach your goal? We're talking about this is what something that's going to be worth $500,000 in the future, but we're asking what do you have to put in right now given a 5% discount rate? So I hope you can see we're using present value of 1. Present value of 1 by the time you reach 30. So it's 10 years at 5%. 10 years, you're currently 20, we're talking 30 years in the future. So 10 years, 5% looks like 0.614 is my discount rate. 0.614 off the table. So I'm going to say 500,000 times what again? Times 0.614, 5%, 10 years, present value of 1. 0.614 is going to give me pretty much like 307,000. Okay. Next, suppose I want to be able to withdraw 5,000 at the end of 5 years and withdraw 6,000 at the end of 6 years, leaving a zero balance in the account after the last withdrawal. If I can earn 5% on my balance, how much I deposit today to satisfy my withdrawal needs? Well, we're talking in 5 years, I'm going to withdraw 5,000, correct? So I'm going to have 5,000 times, what's my discount rate? We're saying how much would I have to deposit today? 5% for 5 years. 5%, 5 years, 0.784. I'm going to leave this off to the side here. 0.784. Let's do our math right here. Okay. 0.784. 5% for 5 years. That is going to be 5,000 times 0.784, 3920. And I'm going to do plus. I'm going to have, in 6 years, I'm going to withdraw 6,000. So it's 6,000 times, well, what's my discount rate in 6 years at 5%? It is 0.746 using the present value of 1. 0.746. Double checking my numbers here. I'm going to do 6,000 times 0.746. I've got 44.76. I add those two together. I have, again, playing with Excel over here on the right. Add those two together, I got 8,396. Right? Okay, suppose you deposit 100,000 in an account today that pays 6% interest compounded annually. To the nearest 5 years, how long before it takes does it take before the balance in your account is $500,000? Let's start with, so we're talking about, we're putting in 100,000 today. It's going to be worth 500,000 in the future. We're not sure how many years, to the nearest 5 years. So I would take 500,000 and divide it by 100,000. As you can see, that's 5. So I'm looking for a future value because I'm talking about 100,000 growing to 500,000. I'm talking about a future value, given we deposit something now at a 6% interest rate of return. So now I'm going to pull my table over here and go, okay, future value of 1, at, pausing here, 6%. What's the closest year? So I'm down here in this column right here, 6%. What's the closest year I can come to? I'm down in this column here before I hit 5 as a factor. Well, you could argue 25 years looks like it's 7.08 away. 30 years is 57.43. Looks like I'm right in the middle of those. I mean, it's like 27 and a half years. I think the exact answer when we look at that is close to 28 years. And I would say 25 or 30 because, man, that factor of 5, it's right between that. Hold on a second here. Future value of 1, 6%. I was in the wrong column. It's right between 4.92 at 25 years and 5.743 at 30 years. I think I'm just going to call it 30 years. If you have 25 years, you're in the right ballpark. Approximately 30 years. Okay. That's one where we had to back into our number of years given a certain rate. That 5 is our factor. I'll just say factor there. Consider an annuity. An annuity means we're putting something in every year, consisting of 3 cash flows of 2,000 each. Okay, that sounds like 3 years to me. So we got 2,000 times 4% interest rate. What is the present value of the annuity? So in today's dollars, given we're going to be putting in 2,000, what is that worth? Like, what if we were to do a lump sum today, given that we're going to be, what's the equivalent of that? If we're going to put 2,000 in for 3 straight years at 4%. I hope I explained that okay. So present value, this is probably one of the more obscure of the calculations, but present value of interest factor for 1 at, so my interest rate, 4%. And when I say interest rate, we should, again, clarify that should be like a discount rate. All right. 4% for 3 years looks like 2.775. 2.775, 4% for 3 years. Okay, 2.775. We come up with, on my hidden calculator over here, times 2.775. I came up with 5550. Now, if you use an actual present value or future value calculator, you may end up with something slightly different than some of these answers. Okay. Again, we put in 3 cash flows. We put in $6,000, right, over a 3-year period. But in today's dollars, the equivalent of that would be less than 6,000 because it's discounted at 4%. This is your challenge problem, number 8. All right. So this is the one where I've got a typo. Solve for PV of an annuity. All right. Yours might say FV, and that's going to just throw everything off. So that's where I messed up. But here I'm going to say, okay, I'm 25 years old and wish to retire in 40 years. I determine I need 50,000 per year once I retire. Okay. With the first retirement fund. So I'm going to be retired for 25 years. Okay. So the first thing you need to determine is in the future, I'm going to be taking out $5,000. How much am I going to need at my point of retirement in the future? How much am I going to need at that point to be able to have 5,000 a year, 50,000 a year for 25 years? So we got 50,000 times present value of an annuity. Now, in this case, the money's going out. I'm pulling money out of my investment account. I'm going the other direction. But for 25 years at 6% discount rate. So this would be present value of an annuity, 6% at 25 years. We're down here at 12.783. 12.783 is what I came up with there. 6% at 25 years. That's how long I'm going to be retired. I'm planning to live. So the present value of that annuity, 12.783. Again, I'm trying to figure out what do I need as far as a lump sum at the point I retire in order to be able to draw 50,000 of money each year. And I'm going to calculate that. I've got 50,000 times 12.783, and that is, put an equal sign in the front of that, Reardon, 63,150. I'm going to need 639,150. Well, now the question is, I'm 25 right now. I'm going to retire in 40 years. How much do I need to put away each year to reach 639.50? So now 639.50 becomes my numerator. My denominator is going to be, what's the factor? What's the present value factor? I'm going to kind of back into this. Well, it's a 6% future rate. I'm talking about future value now. Future value of an annuity, 6%, and I'm going to wish to retire in 40 years. So that's 40. So it's the future value of an annuity at 6% for 40 years. To get me to, so how much do I need to put in each year to get to 639,150? So I'm going to come over here and go, okay, let's pop up here to future value of an annuity. It was 6%, right, Reardon? Yes, 6% for, that's up here, for 40 years. $154.758. See, I've got that right there. 6% for 40 years, 154.758. Where'd my question go? There it is. 154.758. Okay, so What is 639,154.758? What is 639,150 divided by 154,758? I come up with 4,000. I'm going to say 4,130 is kind of what it rounds to. 4,130. Close enough. If you're using an actual financial calculator, it might be something slightly different than that. Now, this is where you have to step back and say, does that make sense? Can I invest 4,000 a year for 40 years? Yeah, that's like 300 some a month. That's like paying myself. Right now I'm investing way more than that. If you were making 80,000 a year, that would be like 5% of your income. And you should be putting at least that amount of money into a retirement account. So I hope that helps. And I'll be giving this video back to those of you that need some assistance with some of these problems. All right, thank you. Let me know if you have any questions about any of these things, because there's a little bit abstract when you start talking about present value, future value, annuity, $1. Understanding the time value of money is so critical when it comes to investing and planning for retirement.